All right, this is our last practice set of 10 problems linear. Just gonna do them mechanically. Again, you pause the video and you try them and hopefully you're getting them, if you've done all 5 sets of videos and done the problems right along with me, then hopefully you've got some skill with this at this point. I am a big believer of the rule of 4. If you do something 4 days in a row, a lot of times the lights come on. All right, so I wrote it in tabular form this time. We're gonna write the equation line through 2 points. I gotta get my science card. Oh my goodness, I keep forgetting, and every time I end up on the other side of the room. And here we go. Let's put the computer in there. Way I can pull it along and know that once it's set to the right height, should be good to go. There, that's fine. There we go. All right. So let's get our y equals. I'm gonna look at the change in y, which is -2. I'm gonna look at the change in x, which is 5. I'm gonna get rid of the 3 because I don't want 3, I want 9. I'm done. Okay, that's just the mechanics, right in the equation below. Okay, next. Slope intercept form, I guess, is what we're doing here. So it's good to multiply positive 2/3, excuse me, times any number. -16/3, and let's bring the 4 over to the other side. And so let's just do this. So let's do 2/3 x minus 16/3. 4 is 12/3. And so our final statement, 2/3 x minus 28/3. Okay, somewhere near -9. Okay, slope intercept, gonna name 4 points on the line. I'll do the x's first. -5 changed by 2, up 2, -3, 1, 2. Start with -7, let's drop 9, -16, -25, -34. Let's check this to make sure it works. And it doesn't. What did I do wrong? 2 plus 5 is 7. I don't like that. So I started with -5, -7, I'm going up 2, up 2. I went up 3. So I see, that's why I checked this. All right, so that would have been -1, that's 1. There we go. All right, 1 plus 5, 6. That goes 3 times. 3 times -9, -27, -7, -34. Now we're okay. All right, that's why it's good to check. Okay, so what are we doing with this one? I guess we're graphing this. All right, so I see -3, 2. -3 gets me 2. We'll call that 2. -3, 2 right there. And we're going up 4 over 5 or over 5 up 4, and it only has to be a ratio of change. So if that's 4, that's going to be a 5-to-4 ratio. And there we go. Although it's not bad to, label a point here, -3, 2. So the reader can see that. And over 5 brings me to 2. And up 4 takes me 6. All right, so it doesn't hurt to throw a couple of points in there to validate what you're doing. All right, in my class, inverse operations, take away 2, multiply by 5, divide by -3. 7 to 5 is 12, so therefore 3 goes into 12. So probably could have divided in here to begin with, but let's get the practice. So we got -25. Yeah, 3/4 makes 75 cents. So -25, doesn't hurt to check it. -25, so that becomes -5. -5 times -3 is 15. 15 plus 2 is 17. Move on. This is all about getting reps. All right, trying to connect neurons in the old brain. All right, problem number 6. Let's multiply by 36. All right, and all of these problems have been explained in earlier videos, so I'm not doing that right now. Just getting the mechanical practice. So that's 8x minus 118, is that right? 90 and 18 is 108. I think that's it. So what you do is you do 3 times 30, and then you do 3 times 6, and you add them up, 90 and 18, 108. 4 goes into this 9 times, so 45x, and 36 times 1 is 36. Okay, so we're gonna bring the 8 to that side, and that's gonna be 37x. We're gonna take 36 away. Let's take 30 away first. 98, 88, 78, take 6 from there, it's -72. So -72 over 37, which is near -2. All right, so does that make sense? Near -2, well, let's graph. Slope intercept form, so let's call that -3. Let's go up 2 and over 9, so I've got a function that looks like that, a linear function that looks like that. +1, let's call that 1. And let's go over 4 up 5, over 4 up 5. Boom, okay, that's an x value that's negative. It's not too big. I'm gonna say I didn't make a mistake. Okay, sketching, all we need is 2 points, so you shouldn't have to manipulate this at all. Hand over 1, 23/8 is the x-intercept. 23/8, okay, so you're near 3 units. It's near 3 units. 23 divided by 3 is, 7, 8 units there, so we're going down 7, 8 units. So if x is 0, minus 23/3. If x is 0, minus 23/3. And there's our line. So if you want an x-intercept, y equals 0. If you want y-intercept, x equals 0. You're gonna hear me say that the whole semester. All right, perpendicular and parallels. Well, if you've been looking at the patterns, you already know the perpendicular. And let's make it go through, what do we want today? Let's have some fun here. Let's go through cat mouse. You give me a cat, I'll get you a mouse. All right, that doesn't seem nice. It's Christmas, for God's sakes. All right, but anyway, 2/9 x minus cat plus mouse. Therefore, the parallel is the negative reciprocal of the perpendicular, so -9/2. X minus cat gets us mouse. Now let's prove it to you that that is correct, so that, effortless effort takes effort. All right, we don't care about the constant, so we've got 2y equals -9x. Therefore, y equals -9 over 2x. So what's parallel to -9 over 2? -9 over 2. What's perpendicular? Flip it and change the sign. All right, we'll make a linear elimination problem here with already the answers. I'm just saving myself some time, so I don't have to check it. If I get the answers, x equals -4 and y equals 3, then I know I've mechanically gotten my practice in for the day. So let's look at 2x plus 5y. Let's see what that equals. -8 plus 15 is -7, I believe. And let's go with 3x minus 4y. Let's see what that is equal to. -12, -12, -24. I think I'm right here. So let's get rid of the x's the first time. Let's multiply that by -3. Let's multiply that by 2. -4x minus 15y equals 21. I believe that's correct. 6x minus 8y equals -48. Let's hope I get -4. So wait a minute, I didn't get any cancellation. What the heck did I do wrong? -3 times 2x is 6x. You probably heard me make that mistake. -15y equals 21. That looks better now. So that cancels. -23y is equal to, take 20 away, -28, -27. Ooh, I don't like this at all. Let's check. Maybe it went way too fast here. Let's start again. But let's keep those here. 2 times -4, -8, plus 15, -8 plus 15. Oh, +7. Come on, old guy, getting slow. 3 times -4, -12, so that's correct. All right, let's go back and do it again. -3 and 2, -6x, -15y equals -21. 6x minus 8y equals -48. Okay, let's add this up here. 69 minus 69 cancels. -23y. Y equals 3. Okay. Little sign error there. I make more mistakes on this problem than anything else I do in math. Now let's go back now. We canceled the x, let's cancel the y's. Should have canceled those first because they were opposites. So we'll multiply this one by 4, that one by 5, and we better get -4 here. So I got 8x, I got 15x. I know that these cancel. Equals 4 times 7, 28. 5 times this, -120. All right, that's 23x again. I like that. Take 20 away and you're at 100, take another 9, 92, and that's 4. 4 times that is that. Ooh, minus. Yeah, I almost made another error. minus 4. Okay, finally. All right, but you're taking more time than what I'm doing. I'm just putting it in front of you and you're seeing if you're getting right answers. So hopefully you did it right from the get-go. All right, that's the practice for today. And now we're going to turn our attention to quadratics in this library series. After that, exponentials, logs, absolute values, so on and so forth.